All right, this is where we're picking up from yesterday. So again, open up to a fresh sheet of paper. Lube Systems, your name. Today's date is the 25th of September. We should be able to get through the rest of this today. So then that way we can move on to other stuff this week and then getting into actual changing oil lab next week. Oh, super exciting. Oh, hey. Hi. There we go. Yeah, we only got roughly about 14 slides remaining on this presentation. However, there's a bunch of slides that are just pictures and just kind of examples of things I want to kind of show you. That's kind of hard to show you when we're all in the shop because cars might not actually look like some of the things I'm going to show you. But let's talk about oil filters for a little while here. So filters are going to contain a bypass valve. Let me go ahead and get my marker up here. So that's going to have a bypass valve. That's what that looks like. I'll show you a different example of what it looks like from a cross-section point of view. But the idea is this. My oil filter is going to filter, obviously, right? As the oil is being pushed through that paper media, it is going to pick up any of that dirt, debris, and whatever that is in the oil to begin with, right? As it's circulating through the engine, a secondary function is for it to clean. So we don't want to force that dirty oil through my engine because eventually that can cause clogs and deposits, which then can actually ruin various different parts of my engine from an internal perspective due to the fact that if those deposits are there, I can't lubricate them. Okay? Over a period of time though, that filter is going to start to get full, right? It's going to filter, eventually it's not going to become very efficient at filtering that stuff out. And if you leave it on there long enough, it's going to get clogged. All right. Unfortunately, that's detrimental to our lubrication system because if my filter's clogged, I can't get oil through it, which now I'm starving my engine of vital lubrication. The oil filter manufacturers understand that this is a problem. So, kind of as a backup system, they incorporate a bypass valve. In the event the filter becomes too clogged to use, that opens up and it literally bypasses the filter to allow unfiltered oil to get into the engine to lubricate it. Yes, that's not ideal because now you're going to be putting deposits in there, but if you don't have any oil, the engine's going to seize up and it's just going to break like much faster. Okay? Think of it like this. If I'm an older individual, right, and I'm like, let's say 80 years old, over a period of time, right, my arteries that are inside my body is going to start to get clogged up. That happens. If I go see my doctor, they're going to do some tests and they're going to say, hey, your arteries are like 90% blocked. That's not good. You're at risk of a heart attack. Right? So what they might actually end up recommending is bypass surgery. It's the same concept. They're going to actually go in and they're going to actually take a tube to bypass that area that's clogged up in your arteries so that way the blood can more easily flow in your system. Okay? My grandfather had quadruple bypass surgery back in the day, and it improved his health because his blood was able to flow better. Same idea with this, okay? So in the event the filter is clogged, this opens up, unfiltered oil is going to then lubricate our engine. Not ideal, but better than our engine blowing up. Here again is kind of an image of what this looks like from a cross section, right? So here's my oil filter, okay? Actually, it's like all in here. Oil's coming in from the oil pump under normal circumstances, okay? And then it's being forced through this paper media. All right, it comes down here, it flows down here as well, and then forces it over here as well. That paper media is picking up all that dirt and debris, and then it's basically going up and then out into the oil galleries to where then it's circulated throughout the engine. Okay? Real simple concept. Unfortunately, again, if this paper media gets too clogged, right? Too clogged, oil can't get pushed through there. So what ends up happening is down here is my bypass valve. The oil pressure builds up so high that it actually can push on this and open this little button up, and then literally unfiltered oil can then go this route out into the engine. So that's kind of fun. During our oil lab, out in the shop, you're going to change oil. Okay, drop the filter, put the filter on, right? Take the oil out, put new oil in. Awesome. Your group is going to get an old oil filter that we have taken off of an actual vehicle that we've changed oil for, like a teacher's car or something. And we're actually going to open it up and take it apart. Most people have never done that before. Okay, you're going to actually pull out these elements. You're going to be able to pull out the paper filter. Okay, you're going to be able to pull out the bypass valve and all this sort of stuff and kind of see this.
Do we have to put them together?
No. We're just pulling it apart and doing kind of an inspection on it. What's interesting is when you cut this paper filter out of the filter itself, you can actually feel all the dirt and debris and gunk that's in there. It's really interesting. And you can see how effective that stuff can be at making sure that doesn't get filtered or gets passed into the engine. All right, during an oil change, the technician notices that the oil filter is swollen. Which of the following is the least likely to result in this condition?
What does it mean by swollen?
Okay, so you ever take a balloon and you blow up the balloon, you add air to it, you go, right? What happens to the balloon?
It blows up.
It blows up. It's swelling, becoming swollen. So imagine that same concept. I got my oil filter. I'm taking it off for an oil change. I notice that it's kind of blown up a little bit bigger like a balloon. Out of these 4 options, 3 of them cause a swollen oil filter. Your job is to go through here and find the one condition that is not responsible for creating a swollen oil filter. That's what we mean by the word least. Okay? Out of these 4 options, what's the least likely to cause that condition? Alright, let me get first hour. Okay. Francisco. There we go, thank you. Also, I don't know why you're staring down. Probably because you're on your phone. Alright, we got everybody? I think I got everybody. Oh, that is a slam dunk. 85% of y'all got that one right. Nice. Let's pick it. Mario, what'd you pick?
Worn crankshaft bearings.
Worn crankshaft bearings. That is the correct answer. That is, out of those 4 options, that is going to be the least likely to cause a swollen oil filter. Okay, and if we think about it and process it even further, right? Let's say A. Okay, we know A causes a swollen oil filter. Unchanged contaminated engine oil. It's contaminated. It's got debris in it, right? That's going to obviously end up depositing that into the filter over a period of time, clogging that filter up. That filter's clogged. We're now putting more oil into it that can actually get out of it. So it's going to start to swell because of the potential for that pressure. So we know A is not the right answer. B, whoops. What is B looking at? A stuck, closed oil pressure relief valve. Well, what's the purpose of an oil pressure relief valve? It's in the name, right? It's going to relieve high oil pressure. If I have high oil pressure, it's probably because something's clogged. And if it's clogged, it's going to start to swell. And if this is stuck closed, meaning it can't open, to relieve that pressure, we're going to get a swollen oil filter. So that's not the right answer. Okay, C, a stuck closed oil filter bypass valve. We just talked about that, right? The bypass valve is meant to open so that way we can get unfiltered oil into the engine. But if it's stuck closed, and we have a clogged up filter, right? That's going to swell that oil filter. So C is not the right answer. A worn crankshaft bearing. Okay, if I have a worn crankshaft bearing that doesn't, or I should say it's not going to impact the oil filter because it's going to impact more the crankshaft. So that is why that is the correct answer, because it is the least likely option to result in a oil filter that's swollen.
So would you physically be able to see that?
The oil filter swelling?
Yes.
Yes. 100%. You would look at it and go, that doesn't look right. Okay, and you would be able to take it off and put a new one on. Cool, that's part of the service. But now you have to ask yourself, why did it swell? Right? Because if it swelled up once, you take off an old part, you put a new part on, it's probably going to swell again. You didn't fix the problem necessarily, right? Maybe you need to change your oil more often, or maybe you need to buy a better brand of oil filter, or maybe you need to take a look at your oil pressure relief valve. Maybe that's faulty, right? It leads you to the next step of asking questions. All right, oil cooler does exactly what it is. It is going to take the oil as it's being run in the engine, and again, the oil is going to get hot because it's inside the engine where there's heat because we're burning gas. All right, and we're trying to regulate the temperature of that oil so it doesn't get so hot, right? Because if it gets so hot, we actually start evaporating that, and that causes additional issues, which we're not going to get into today. So what we end up doing is literally taking that oil, bringing it up to the front, kind of like a radiator, if you know what that is. Air passes through that, drops the temperature down, and then that cooler, not cold, but cooler air, or cooler oil, is then, actually I'm going this backwards on this. It goes this way through the filter, and then back into the engine. Okay? So here's what we actually see. Line coming in here.
And that's right in front of the car, isn't it?
It should be, yes. We want as the maximum amount of air flowing through that we can get.
Drift cars, when they don't have their front, they see that thing.
Yes. Now there's a bunch of other things that we put up there, right? We got our radiator. You could have your transmission cooler.
Yeah.
You could have a your air cooler for your turbo, maybe if you got one of those. I mean, we stack things up in the front, and air is all coming in here and trying to go through this, which is kind of fun.
Wouldn't it be hotter cause it to like not move as well because it's thicker?
It could be. It becomes so runny that it doesn't stick, or the oil film isn't developed as well on those parts. Yeah. So again, like anything, we're trying to look for the Goldilocks range, right? We don't want it too hot. We don't want it too cool. We want it just right. Yeah.
Is the radiator oil cooler like connected to a certain level or not?
These two are not connected.
Okay.
Yeah. Coolant's going to stay in coolant. Oil's going to stay in oil.
You don't
Yeah.
want them to mix.
No. You never want those to mix. No, they're going to be in the same vicinity potentially, right? Just due to the fact that that's where the air is going through. But I mean, you theoretically could put this in a different spot, so long as you have like an air duct.
Still need airflow.
Or yes, you still need airflow. All right, PCV. Again, I want to iterate this because I did talk about this a little bit on Monday. The PCV valve is really linked up with our emission system. Okay? But it does interact with our lubrication system, so that's why we're going to at least mention it now, so that way you kind of have an idea of how it interacts with the lubrication system. Now, PCV stands for positive crankcase ventilation, and again, it's named after its function. It does what it says it does. It's going to ventilate the positive pressure that's in our crankcase. Well, how in the world do we get positive pressure in our crankcase? All right, so what ends up happening, right, here's my air intake. Air is coming in here, right? It mixes with the air-fuel mixture through a fuel injection. it goes and enters into the combustion chamber, right? It burns, and we have piston rings, however, that to try to prevent gas blow-by. But sometimes we're still going to get some gas that goes past the piston and the cylinder wall. Okay, especially on older engines. Now what happens is that gas is going to leak into our crankcase, which is this yellow section right here. Okay? And it's going to literally pump it up like a tire or a basketball or a soccer ball, whatever you want to call it. Okay? It's literally pumping it up. Boom, boom, boom. So it's going to start to have greater pressure than what's out here in the atmosphere. If that becomes so severe, now what we're going to do is that positive pressure is literally going to push the oil, which lives down here, by the way, out through our front or rear main seal. Okay? Maybe it might even spill it out our oil pan gasket. We got an oil leak, right? Which is not good, because I'm going to start losing oil. To help alleviate that, we actually have something called the PCV valve. Okay? It literally takes all that additional pressure and it basically creates a path for it to travel on that allows it to actually come up and be recombined with the incoming air, so that way we can burn it. And we recycle it essentially. So that way we're not just letting it out into the environment to cause pollution, okay? But what we're doing is we're utilizing that in our process here, so that way it's not damaging anything, okay? So basically the PC, positive crankcase ventilation system, is really there to relieve the crankcase pressure so we don't get oil leaks. I'll sum it up like that, okay? We'll talk more in depth about the PCV valve in a month or two when we get into our emission system. But just want to let you know that that system is designed there for that function. And again, here's just kind of another picture of that, right? So again, this is what a PCV valve might look like on a vehicle. Whoa, 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 here we go. What it might look like on a car. They're really small, they're about this big. They're super easy to replace, typically. They're very cheap to replace too, because it's essentially a check valve. Okay, so inside my crankcase, okay, I'm burning fuel. I'm literally sucking up those extra pressure. It's flowing through this. Here's the incoming air, right? Comes down through here, gets mixed in with that, and then recycled back there, and just kind of a process that keeps running around, which is kind of fun. Again, just kind of this is kind of a cross section of that valve. I'm not going to get into that right now. All right, this is a fun picture. What's going on in this picture?
Lots of engine sludge.
Lots of engine sludge. Where is this in the engine? Let me ask you that question first.
Crankcase. Not crankcase. That's amps.
So what are we looking at?
Valve head.
Okay, cylinder head. What did I remove in order to see this?
Valve cover.
Valve cover. Okay, the valve cover. Remember, the valve cover is a hat on our cylinder head. I literally took the hat off. Right? Now if I come in here and draw this, just so that way you can kind of keep track of where we're at. Come on. Right here, right? It goes all the way around here. Okay? This is where the valve cover would sit or be bolted to.
What causes sludge?
Oil breakdown.
Oh.
Just straight up. What's happening in this case is this particular vehicle, the owner of this vehicle, was not changing their oil as frequently as they needed to.
Or properly.
Okay? Well, what happens again, as that oil is circulating, right, it's heating up, right? As you heat the oil up, it breaks that oil down over a period of time. Just that it's not going to be infinite lubricant. Okay, so it breaks down. Now again, we say 3,000 to 5,000 miles, you need to change your oil. This person probably is just like, I'm good. and they let it go 10, 15, 20, 25,000 miles, right? And there's no problem with it. Hey, my car's running fine. Why do I need to change my oil? What they don't realize is they can't see what's actually happening here. The oil's, again, breaking down. It's becoming chunky. It's sticky now. It's not lubricating. Now when I do change out my oil, this stuff isn't getting changed out, so the new oil is getting in here, and it can't get to the parts that actually are metal-on-metal contact. Okay? So now you have parts wearing out, even though you have fresh oil in it. This stuff builds up, meaning that it's now more difficult for this stuff to actually function properly. It doesn't drain as well. It actually is kind of like a blanket on top of my engine. So now I have additional heat that I didn't need ahead of time.
And that stuff will heat up and won't cool down.
Right? Which means my new oil that I just put in is going to break down even faster. Okay? So this right here is a perfect example of why you need to maintain your engine by changing your oil at frequent intervals. So that way this stuff doesn't build up. Okay? Now, how can I fix something along those lines?
Get a new engine,
Right? How can I clean this up?
power oil.
Okay, imagine like this is a human body. Let's say it's a person, right? I'm like 400 pounds. I eat cheeseburgers and donuts every day, right? Here's what the inside of my body looks like. This is all fat.
Under your fat ropes.
Okay? Now, for me to clean that up, I gotta exercise, I need to eat more vegetables. Okay? Over time, your body's gonna clean yourself out. You're gonna lose weight. Engines, you can't feed it like vegetables and take it on exercise. So I need to go 100 miles an hour, officer. I need to take out my car for exercise. Can't do that, okay? What you can do is you could theoretically get some engine cleaners, like seafoam, right? There's various things on the market you put in with your oil change. As that circulates, it's going to come in contact with this, and it's going to break this stuff down, and it's going to then
Oil.
get down in the oil pan, so then that way it cleans out with the next oil change. Okay? Now, this is a very extreme situation. You could probably do that. It might help a little bit, but it's not going to help out to the point where it's going to actually make this thing like brand new. This thing needs like a severe case of probably replacing stuff. Yeah.
You put seafoam in your oil?
Oh yeah.
What? Mason, where do you put your seafoam there?
Gas tank.
Oil. Yeah.
Yeah. Keep in mind, seafoam is a petroleum product, so it can go in oil, it can go in gas. Yeah. Typically, I've done this in the past with my older vehicles. Probably like 3 weeks before I change my oil out, I'll dump a bunch of seafoam in my oil, right? As a cleaning agent, right? To really kind of scrub up everything. It deposits it out, I change my oil, boom, fresh oil in. You'd be surprised at how well that stuff works. Yeah.
How frequently should I change my oil on my or ATV?
I would. The answer is going to be very simple. I'm going to say, check what the manufacturer wants you to change it to.
Like 15 hours.
I think it's every 10 to 15 hours.
Yeah.
Okay.
Right.
Depending on what you're doing.
It's whatever. Like I would, if you asked me that for a vehicle as well, that would be my answer. Whatever the manufacturer recommends.
Change it more often than you think.
Yes. You will never have a blown engine. You will never have a dirty engine if you change your oil too frequently. Okay? It's only if you leave it unchanged for longer.
All
right.
You're on seafoam.
That's personal use.
Seafoam doesn't work.
No, seafoam's not gonna.
It's
not gonna hurt you too bad. Actually, it's not gonna hurt you at all. All right, oil pressure switch. Oil pressure switch or oil sensor.
basic.
This is a device in the oil galleries. Okay, let me point that out. This device lives in the oil galleries, or it's bolted into the engine block, right? So imagine this for a second. Here's my oil switch or oil pressure relief valve. I bolt this in. This section right here is in the oil galleries. It is checking the oil pressure that is being produced by my oil pump. Well, let me back up. The oil pump really doesn't produce oil pressure. All the oil pump does is circulate the oil. Okay? Oil pressure is developed through the bearing clearances. Okay, so I got my crankshaft and my rod bearings. You know how we had like 0.02 of an inch around that? By pumping oil into that, that is what creates your oil pressure. Okay, now that pressure is going to be throughout the entire system. This sensor monitors how much oil pressure is in the system. And again, if the oil pressure is too low, it's going to do one of two things. It's going to turn on an indicator light on the dashboard of your car. Right? The little symbol's going to pop up. Boop. Hey, I got low oil pressure. What is the number one symptom of low oil pressure? What causes low oil pressure?
Not enough oil.
Not enough oil. Okay? So it's letting you know as the operator of that vehicle, hey, you don't have a whole lot of oil in here because we have low oil pressure. Now, there are other reasons for that, but you might want to get out and check your oil level. Ooh, I am low. Boom. I can now add more oil so that way I don't starve my engine and cause a big problem. Okay? Now, there could also be a gauge or something that actually shows you that as well. Now, the other option that probably, at least on newer cars, that is more likely, I wonder if this is going to be the next slide here. Okay, this is, so right here, oops, right here is my oil pressure gauge on this particular vehicle. Okay, you might have something that looks like this, right? Gives you a needle. More often than not, you're going to see like this light. Okay, you see that light turn on your dashboard, right? Looks like this, it's just really big. That's danger, Will Robinson. Danger, danger. You guys don't know that reference, that's fine. Okay? Looks like an oil can, not good. Or if it's really on the low end of scale, not good either. Modern day vehicles are getting smarter because that oil pressure sensor is hooked up to your car's computer. That car's computer is programmed to say, if I have low oil pressure, I need to turn that light on to communicate that with the operator. Cool. However, if this is illuminated or it's triggered through the computer system is going to prevent you from starting your car. Right? You're out in the parking lot, trying to turn the key over, you're like, why is my car not running? What's the first thing you're probably going to think about?
Broke.
Yeah, it's broke. Okay, what's the number one reason why I can't start my car?
Battery.
Battery's probably dead. Oh, my stupid battery. I knew I needed to get a good one. You go out there, you check the battery. Hey, wait a second. My battery's fully charged. Why is my car not running?
Gas.
Could be gas, right? You're going to go through the process. Well, I just filled up yesterday. It was running fine. Got a full battery. It could be. Maybe your oil level's too low. Most people don't check that. Because again, the car is smart enough to realize, hey, if the oil level is too low, I'm going to break my engine. I don't want to break my engine, right? So I'm not going to start the car and run it. The operator is going to be very mad at me, but it doesn't matter, okay? Because they're stupid. They don't realize that I'm not in good health. So just understand that there's safety factors here built into the vehicle, right? That's going to help prevent that from happening.
So what do? Call somebody? Come here?
Check your oil level. Add more oil. That
What
might.
if you just don't have oil in the backseat?
Then you got to go get some. Time to start walking.
What if we come here? Will you give us some oil?
Nope, I don't have any oil. Vehicles may also have a low oil level sensor. So not only are we checking the pressure, but we could also potentially have our a low oil level sensor. Here's my oil pan. Here's my oil filter. Here I've got maybe a particular sensor that's monitoring my oil level. If it notices that level's getting too low, it might trigger similar things, right? Might prevent you from turning or starting your vehicle, or it's going to at least show a light, okay? Which is always fun. Again, that's a better picture of that. Not every vehicle has that. Oil dye, okay? Keep in mind, this is actually some stuff, come on now. This is stuff that we can add into our crankcase, right? Hey, I've got a leak. I don't know where it's coming from. We add oil dye, we circulate that, we drive the vehicle around. We then can get underneath the car with a UV black light. We can start looking around. Oh, guess what? It's going to glow, right? It's going to say, oh, there's some oil dye in my oil. Then we just got to trace where it's coming from. Then we just figured out where the leak is at, which is kind of fun. It makes diagnosing that stuff very easy if you don't know where it's coming from. Oil pressure test. Again, what we can do is we can take that oil pressure sensor out, plug in an adapter, and when we run the vehicle, we can actually monitor what it says there instead of running it through the computer. Because sometimes that oil pressure sensor could malfunction. This is our way of testing that to see if the sensor is actually working properly or if it's lying to us. Not too good. Okay, so we can do an oil pressure test by plugging a gauge into that same spot on our engine block. I'm trying to hustle through here because I know we got 3 minutes here. All right, this is going to take us all the way back to Monday. Each of the following is an engine lubrication system function, except for, okay, that word except indicates that one of these 4 options is not an engine lubrication system function. Okay, we're thinking primary functions here. Oh, yeah. Let's see if I can get everybody. I think I'm getting everybody. Okay. We're going to say that's good. Yes. This one here is crazy. Only 14% of you guys got that one right. Easton, what'd you get?
C.
C is the correct answer. Okay? So, let's talk about this real quick. Engine lubrication system function. Is it there to clean the inside of the engine? Yes.
Default.
Okay? Does it help cool the engine parts? Yes, it does. It's not its main function, but it does do that. Does it help increase the fuel economy? Well, when my engine is properly lubricated, yes, because it's easier to turn stuff. Okay? Does it prevent heat transfer? No, it actually helps heat transfer. That's why C is the incorrect, or that is the correct answer because it is not a function.
It's a problem.
Hey folks, just real quick, we're not done yet. Go sit down. Go sit down. We got 2 minutes. Sit down. Sit down. Okay? Typically on most of our presentations, I'm also going to introduce you some tools that you're going to need to use for our oil change lab. We have a whole bunch of different varieties of oil filter wrenches. Okay? So, when you go out there and actually try to take an oil filter off, you're going to notice that it's going to be a little difficult because sometimes they're really tight. There are specialty tools that their entire purpose in life is to assist you in loosening up that oil filter. These tools are only used to loosen. We never, ever, ever use tools to put the oil filter on and tighten it. Oil filters should always be hand tight. Okay, yes. That's why we only put them hand tight, because if you use one of these to put them on, you're never getting it off, because it will tighten over time. Kind of crazy. A lot of mine are red because, yeah. All right, have a good one, everyone.